Here we are talking about formation of non-systematic cyclic code or encoding of cyclic code. Before that, we should know what is non-systematic code word. We know that a code word is a combination of information and parity bit. That means if C is a code word, it consists of information bit, suppose I1, I2, I3, which is up to n number of, if n is not mentioned, then we write the parity bit P1, P2 up to Pn minus k. It means the information bits are separated from the parity bit. But this is for systematic formation of code word. In case of non-systematic code, the information bit and parity bit are not separated by each other. They are mixed up. That means it may be first bit of the code word is information bit, then second bit is parity bit, again information bit, 2 bit are information, then again 2 bit are parity bit by this way. That means information bits and parity bits are mixed up for a non-systematic code word. It is non-systematic. In case of systematic code word, these 2 bits are, that means information bits are parity and parity bits are separated. For these 2 case, that means for non-systematic code word and systematic code word, for encoding purpose we need to consider 2 different methods. And in your next few classes you will teach, you will know how the encoding process can be done. Again, another important factor you have to remind that in cyclic code, code words are not in word form, rather than they are in polynomial form. That means in case of linear block code, the code word is denoted for linear block code. Code word is denoted 1010 in this format. But in case of cyclic code, the code word is denoted in polynomial format. For example, x plus x square, x cube by this way. This is the polynomial formation of a code. Now, how a polynomial can be created? Suppose a code is given to you 1010. It is a code given to you. Now, if we consider or if we convert it into polynomial form is represented by p. Suppose. So, the first bit of the code word is denoted by, that means we have to consider the least to first. It is the first bit, it is the second bits, it is the first bit, it is the second, third, fourth. We have to consider from from right to left. So the coefficient of the least bit will be 1. Again, for next bit it will be x into 1. This 0 is for here and the coefficient is 1 always for the least bit. Then the second right bit should be x, and the bit which is represented here is just multiplied with this x. Similarly, in third case, again 0 is placed, and with this polynomial, with this x square is added or x square is multiplied. Again, the fourth bit is 1, and with this x to the power 3 is multiplied. Now, if 1 is multiplied with 0, it is 0. x is multiplied with 1 is denoted by x. 0 is multiplied with x square is also 0. And 1 is multiplied with x cube, that is x cube. So our final polynomial is x cube plus x. By this way, you can easily convert a code word into its polynomial form. Let's take another example. Suppose C2 is equal to, it is C1, suppose C2 is equal to 0, 1, 1, 1, 0. So, to convert it in polynomial form, we have to consider it is last bit, that is 0, 1, 2, 3, 4. So, the fourth one will be represented as 0 into x to the power 3, as it is not x, it is 1. So, for the second bit we consider x. So, therefore it is x cube. Then we add, again write 1, this one, and it is x square. Again add 1 into x is x, and last one 0 into 1. So our conversion is x square into x. I think one is already. Sorry, this is 4. It is not 3. Because it is 0, it is 1, 2, 3, 4. So therefore it is 4. Again it is 0 into x to the power 4 plus 1 into x to the power cube plus again 1 into x square, 1 into x, 0 into 1. That means your answer is x to the power 4, x is cube, x square, x. So this 0 into x square is multiplied when it is 0. So x to the power 4 is not considered here. So your final answer is this. By this way you can easily calculate the code word or the polynomial form if the code word is given to you. So an exercise is given to you. Suppose 10101 is a code word. You have to find out the coded polynomial. Another one is 010110. In both cases, it is first, it is second. You have to find out the coded polynomial. Try yourself. So, now we have to consider another technique, that is polynomial multiplication. Suppose two polynomials is given to you. P1x equals to x cube plus x square plus x, and P2x equals to x to the power 4 x square plus 1. If we want to multiply these two polynomial, we have to write P1x into P2x by x cube plus x square x into x to the power 4 x square plus 1. Then we have to multiply each bit by another. So first, when x cube is multiplied by these three, whole 3, x3 is multiplied by these 3. Second one, x square is multiplied by the whole second polynomial, and x is multiplied the second whole polynomial. So it will given when x3 is multiplied into x to the power 4, it will be x to the power 7 plus is added, so we have to add plus. So x cube is again multiplied with x square, so it is 5, and last one is x cube, as 1 is here. Again we add plus this for this plus, and x square is multiplied with x to the power 4. So I write x to the power 6. Similarly 4 and x square. Again for third case it is x to the power 6, x cube and x. Now if in the whole list same bit is repeated, that means this x3 and this x3 is repeated here. So we can omit them. These two can be omitted. Similarly, check whether any other bit is repeated here or not. See, x to the power 6 is already repeated here. So it is also omitted. You can omit them. So what is present? What is left? List. This is x to the power 7 is there. Then x to the power 5 is there. X to the power 4 is there. X square and x. So it is our final answer for this polynomial multiplication. So hope you can understand the multiplication techniques. Let's see another example. Suppose one polynomial is x square. Another polynomial is x to the power 4, x cube, x plus 1. So when we multiply this, we have to write x to the power 4, 3x plus 1 and x plus x square. When added, x4 is multiplied total of this. Again, x cube is added with this, x is added with this, and 1 is added with this. So our answer will be x to the power 5, 6, 4, again 5, x square, x cube, x square. Now omit the term which is repeated here. X 5 is repeated, x square is repeated, nothing is left. So our answer will be x to the power 6, x to the power 4, x cube, x. So by this way you can calculate any two polynomial multiplication. So here is your another exercise. Suppose you have two polynomial P1 x is x plus x square, x to the power 4, x to the power 7, and P2x is x cube, x square plus 1. Multiply these two. And compute the resultant polynomial. So this is all for this lecture. See you in the next class. Thank you.